FPV, first person view. One of the most important upgrades you can make to your FPV system is your video. I've been flying analog ever since I got started with FPV, and let me tell you, it has been a blast. But I decided it was time for an update. And that's why we're going to be taking a look at the new Fatshark Sharkbyte HD system. Stay tuned. There's a lot of different options for FPV. However, HD can be a little on the expensive side. So I decided, let's go ahead and invest into the Sharkbyte HD system since I already had HD3 goggles. Granted, I don't have the OLED screens, so my FPV is not going to be the absolute best that it could be with this new system. However, I am curious to see how much of an upgrade this system is going to be on my HD3s compared to my analog setup. We're going to go over how to install the Sharkbyte system onto the goggles, into the quadcopter. We're going to be using both the 200 milliwatt version Sharkbyte for the 3-inch quadcopter, the 3-inch Japulora. We're also going to be mounting up the 500 milliwatt double stack version of Sharkbyte in my 5-inch quadcopters. And we're going to be flying those around and testing and seeing just how much of an upgrade is the Sharkbyte to my existing analog system. And with using the older HD3 goggles. How is my FPV going to look? We're going to find out. And make sure you haven't already, you like, share, and subscribe. Make sure you click that bell icon so you get notified first when I put out new content. Taking a look at the Sharkbyte HD system bundle kit here, comes with the RunCam Nano HD camera. And you can see we have the camera here, along with the smaller bracket and the ribbon cable. This is a shorter style ribbon cable, but this should fit perfectly in the 3-inch Japulora frame. And we have some extra hardware. This is the camera and everything it comes with, as well as a lens cover. Taking a look at the TX5 S.1 single stack 200 milliwatt Sharkbyte VTX. This is the single stack board. Comes with this nice little adapter plate so you can mount on your 20x20 and 30x30 stack. And the board itself is a Whoop size. You can fit in your Whoop style quadcopters. Also comes with this 50 volt 330 microfarad low ESR capacitor, which we will be using. Taking a look now at the Sharkbyte Vrx video receiver module that will attach to our HD3 goggles or any other goggle that has mini HDMI input. It has 2 patch antennas on the front, right hand circular polarized, as well as 2 antenna connections on the top that you can use for Omni if you wish. Now this is the little control board that you can connect to the video transmitters to change the power band and channel if needed. The cover for the fan that will hold the Vrx module. This power cable that takes 3 to 4S LiPo power input to power the goggles and the Vrx module. Also have another connector here that would plug into your balance connector on your existing Fatshark battery case to power the Vrx module, and the mini HDMI cable that will hook from the module to the goggles. Also a firmware flashing cable here. This is everything that you get in the bundle kit that comes with the single stack board. We're also going to be mounting up the 500 milliwatt double stack board with the Foxeer DigiSight camera HD. Okay, let's go ahead and get the Vrx module connected to the goggles. You're going to need a small Phillips head screwdriver. Remove the 4 screws on the vent cover, and if you lose a screw, it's okay. They do give you screws in the bag with the Vrx module. Go ahead and pull off the existing cover. Take your new cover here that came with the bundle pack, and it has plenty of extra screws in here. Go ahead and screw it down onto your fan cover. This should fit other fan models as well. I have seen other goggles that has worked with. And screw those down till they're nice and snug. Now you have the connector sticking out the front, like so, that we will be able to pivot and connect the bolt. Now when you run the bolt in, it must go one way. So you're going to come in from the left side with the bolt head, push through, connecting the VRX module, and then you'll take the lock nut, 5.5 millimeter, and you're going to go ahead and put that on hand tight. Then you'll go ahead and get your driver, and you're going to go ahead and snug that down, but don't go too tight. If you go too tight, you won't be able to actually pivot the VRX module, which I feel can be a little bit of a benefit if you tend to move your head down. You can actually pivot the VRX module up to compensate for you lowering your head. So just go ahead and tighten that down. Like I said, you don't want to go too tight, because if you go too tight, it won't move, it won't be able to pivot. But you'll be able to feel it when it starts snugging up, and then just back it off a hair. See, if it's too tight, it won't move, it kind of locks it into place. Go ahead and just loosen that up a little bit, and then you'll see you'll be able to pivot it to allow for your head when it moves down. Also takes a little bit of the strain off of the fan cover itself. Okay, now all we have to do is connect the mini HDMI cable to the VRX module. Push that in so it's nice and secure. Then the other end will plug right into your goggles, wherever your mini HDMI input is. On mine's on the bottom. And the placement of the cable is not bad. It doesn't really get in the way. However, it does block the on-off switch. You're able to get the diopters no problem, and it kind of blocks the micro SD card slot as well. But you're able to move it around to, access the micro SD card if you need, and to get to that switch. It is a little bit of flexible cable that helps out. Alright, so there's the VRX module mounted on the goggles. As you can see, it doesn't interfere with the analog receiver bay on the right hand side. Even with the new HD VRX module in place, I can still have my patch antenna for my analog set up right alongside the Fatshark Sharkbyte. Okay, we're going to go ahead and use the right hand circular polarized SMA antennas. I'm going to use these Lumineer axes. And actually, I'm going to change these out later on for the flight. I'll actually be using the double omnis, 2 of those. I purchased an extra one that we'll be putting on for the testing of the video, which we'll do later. Alright, let's go ahead and take a look at the single stack 200 milliwatt Sharkbyte TX5S.1. You can see we have 4 pads here that we're going to solder. We have a connection here for the firmware, as well as for the joystick controller. We have a connector here for our HDMI. You see we have left to right, we have ground on the left. Next we have voltage, which is 7 to 26 volts to power the video transmitter. We have a RX pad, which will solder to a TX pad on the flight controller. And we have a TX pad, which we will solder to a RX pad on the flight controller. I'm going to go ahead and get the wires all pre-tinned, as well as a video transmitter. We're going to go ahead and tin those 4 pads, just like so. Really easy to solder. The pads are good size. We're going to go ahead and pre-tin the 4 wires that we're going to solder onto the video transmitter. A little bit of solder, fresh solder on those wires. And we'll go ahead and work from left to right. Ground, power, TX, and RX. Make sure you take note of what colors wires you're using for your TX and your RX for when you go to solder onto your flight controller. Okay, we went ahead and removed the analog system that was in my 3-inch Japulora. We're going to mount this right on top of the flight controller. You see we have the ribbon connector connected to the camera. Now we're going to go ahead and put the board on top, and I'm just going to use some foam to stick that down. Go ahead and stick the ribbon connector facing this way. Push it down till you hear the clicks. When you line it up, you'll have it locked into place really easily. You see the antenna we're using is just a stubby Omni antenna sticking right here off the frame with a UFL connection. They do give you a zip tie. You can go ahead and run that zip tie through the board, and that's going to support the connector for the antenna as well as the camera wires. Go ahead and solder up the 4 pads on the flight controller. We're going to be using the 9-volt pad and the ground, and the TX and the RX pad. So we're just going to do the TX pad of the video transmitter to the RX pad, and the RX pad to the TX pad. Go ahead and give them a twist. I'm going to go ahead and mount that on top with just some little foam, some sticky foam I got from the dollar store. Works really well. As you can see, it's all in there. Have plenty of space, as well as able to access all the ports. Okay, to power the goggles, I'm going to be using a 5000 milliamp Goldbat 3S LiPo with an XT60 connection. That's going to power right into this cable. Now let's go ahead and get the micro SD card set up. We're going to go ahead and put that in the computer and format to FAT32 per the Fatshark website. Go ahead and format your micro SD card. Once your format is done, you can go ahead and close that out and go to the fatshark.com website. Now we're going to go ahead and go to Sharkbyte and scroll all the way down to the bottom, and you will see it says software updates. Go ahead and click on that. Go ahead and click on Sharkbyte, and then you have two firmwares, one for the goggle module and one for the VTX. Choose the VTX for which one you're using, and you're going to go ahead and save that to the micro SD card on the root of the micro SD card. Okay, go ahead and push in the micro SD card. I'm going to do the video transmitter flash first. Push that back into the module. Go ahead and connect your firmware flashing cable to the Vrx module. Connect the other end to the Sharkbyte 200 milliwatt board, and then you're going to power up the goggles only. Do not power up the quadcopter. Just the goggles need to be powered up. Once you power them up, you'll see on the screen it's going to write the HD0TX file to the video transmitter, and then repower your headset. Go ahead and take out the micro SD card, and we're going to take the micro SD card, we're going to put it back into the computer, and now we're going to download the RX, the receiver firmware, onto the root directory of the micro SD card. Once that's done, go ahead and save that to the micro SD card, copy it, and paste it over to the root directory of the micro SD card. Once you have that completed, you'll see the transfer says complete. Now we can go ahead and remove the micro SD card from your computer, put it back into the Vrx module. Make sure you disconnect the firmware cable. Now go ahead and power up the goggles, and now you'll see it does take a little bit longer to flash the Vrx module, but go ahead and let it write and then repower your goggles, and now you'll see the Sharkbyte is ready to pick up on the video signal. Okay, we're going to go ahead and take a look at the double stack 500 milliwatt version of the Sharkbyte, and you'll see it has an MMCX connector as well as a firmware flashing connection here on the front. Also has an MMCX connector here to hook for your antenna, and it also has a joystick connection to change the channel and band and power. Okay, on one side you have the power, 7 to 26 volts input and ground, and if you flip the board upside down, you will also have two more solder pads that are the RX and the TX pads. Once again, TX goes to RX, RX will go to TX. We're using the Foxeer DigiSight HD camera that does both HD and analog. We're using the HD, and that's what we're going to mount in my 5-inch quadcopter. I'm going to mount it in the front of this build, and you want to make sure that you disconnect the board with the 4 screws, connect your camera cable by pushing down and locking into place, and then go ahead and put the 4 screws back onto the double stack. Make sure they're nice and snug. Mounting this on the front with some sticky foam here that will keep it soft mounted in the front. Okay, you're going to go ahead and get into Betaflight. Go ahead and download the newest configurator, 10.7.0. Scroll down to the bottom to see what version you're going to go ahead and use for your PC and your software. Once you're in Betaflight, you need 4.2.8 or newer. Going to go ahead and go to the ports tab and go ahead and turn on Serial RX for the UART that you soldered your video transmitter to. I use UART 6. You're going to go ahead and save and reboot. Make sure your baud rate is set to 115/200. Now go ahead and go to the CLI tab. You're going to have to type in set space OSD underscore DisplayPort underscore device space equals space MSP and go ahead and hit enter. That's going to go ahead and get your flight controller to be able to use the canvas mode to have the on-screen display with the Sharkbyte HD. Now you're not done yet. You have to type in one more piece of code in the CLI, and the number that you're going to use is going to be one number less than the UART that you used. So for mine, I used UART 6. So I'm going to go ahead and type in set space DisplayPort underscore MSP underscore serial space equals space 5. One number less than the UART I used, which was UART 6. Go ahead and type save, and your OSD is all set up to use for canvas mode. Let's go ahead and take a look at the OSD on the camera. Okay, to access the camera menu, you're going to go ahead and take your controller with both sticks centered. You're going to move the left stick. You're going to basically yaw to the right, and then you should be able to pick up your menu here and use the right joystick to toggle through the menu for your camera, and you can change the settings in the camera. Okay, in order to access the VTX menu, you're going to go ahead and have both sticks centered. You're going to move those sticks in towards each other in this configuration, and that's going to pull up your VTX menu where you can change your channel, your power output, and you also have low power mode, LP mode. LP mode will have the quadcopter at 25 milliwatt until it's armed. I'm going to go ahead and make sure you save and exit after you make any changes, and then I'll bring you back outside the menu. Alright, show you what we're working with today. We got the 3-inch Japilora with a Sharkbyte 200 milliwatt VTX, outputting 200 milliwatt. We got the Flywoo little Omni stubby little antenna we're using. We're using the Ovonic 850 80C battery 3S. We've got the Sharkbyte module with the Lumineer Axi antennas, the doubles. And for the battery, for the power up the Fatsharks, we're using this Goldbat 5000 milliamp 50C pack. Alright, as you can see here, we've got the 25 milliwatt output power on the Japilora. I was getting a little bit of jello, so I probably just need to tighten up the camera mount a little bit more. But you'll see at 25 milliwatt, this will give us a better idea of how to see the breakup. Watch especially when I go around the trees, and then you see where I'm facing. Watch as I go straight ahead and see how the digital breakup, this is how it breaks up. So definitely different than obviously your DJI systems. It's a different kind of breakup. It's almost more like an analog static breakup. But at 25 milliwatt, pretty impressed with the range and the clarity of this video, especially with the short stubby Omni. You can see right there it really started to get bad. That's when you want to definitely turn around. That's about the limit for the 25 milliwatt. We're going to go ahead and take a look at some 200 milliwatt output power flights as well, and the 500 milliwatt output power long range flight with the 5-inch Impulse RC Alien. Alright, this is the 200 milliwatt flight with the 3-inch Japilora. I'm going to be flying down low and going behind myself and the buildings. And in between the buildings are firewalls, so this is a good torture test for this VTX. Lots of Wi-Fi also around this particular area. And you can see back where I am facing, right there, and where the blue porch is, I'm facing the street. So when I go behind myself, this is the ultimate test of penetration for the Sharkbyte at 200 milliwatt. You can see it is struggling a little bit, but I'm able to see enough to fly. So you can imagine if I was facing the quadcopter the entire time, how much better it would be. This is going behind myself now. It's going through all those firewalls, the building, and then we got some trees as well. And you can see, even that it was struggling pretty bad with the penetration, it still was able to get through. So I'm not going to complain about the 200 milliwatt. This is the 5-inch Alien with a 500 milliwatt double stack VTX, and with a much better antenna, longer antenna on this one. So we should be seeing some better results than when we did with the 200. You can see there when I did the flips, it did struggle a little bit there, got a little bit of breakup, but nothing that you can't manage. I do like the image quality overall better than my analog, for sure. I can see a lot more details in the leaves, and it's much more of a vibrant color as well, like a lot more contrasty than my analog setups. And the breakup is really, it doesn't bother me, and it actually kind of feels right at home, like the way my analog breaks up. So we do a little bit of freestyle testing here, and then we will do a short little range test just to see. Up high, I'll go away from myself, far away, and we'll see how well the signal does. And then we'll go down low a little bit and see. And then we'll also we'll fly behind myself to see what kind of penetration we can get from behind. Keep in mind we're using the 2 double Omnis Lumineer Axi doubles, and we're also using the patch antennas that come with the Sharkbyte. But as you can see, I'm definitely getting some decent range out of it for sure with the 500 milliwatt. A little bit of static, and you'll see more when I go to turn, because right now the back antenna is facing where I am. But once I go to turn around to come back, that's where we're going to lose even more because of the battery. The battery is blocking a little bit of the antenna. You can see as I turn, it's going to get really bad here. So it's really struggling now. It's definitely, the antenna is not facing me. So that's about the limit right there, I would say, to be able to go out and come back, which is more than adequate for me because I don't really fly long range most of the time. Mostly it's just freestyle. So Sharkbyte will work really great for freestyle. If you're flying some bandos, you definitely got some penetration to work with, as well as, you know, getting through some trees. And if you do get away from yourself a little bit, you can see the range. Pretty impressed with the 500 milliwatt on this one. Now we'll go ahead and fly behind myself, and we'll see the range on that and see how well that works. So you can see this is the ultimate test for this, because I am now behind myself. So I'm only using basically the Omni antennas going through the building. I'm using penetration going through the school building, as well as, you know, the distance between the Omnis and then the battery on the quadcopter as well when I turned around. So not bad. Now I have also tried DJI FPV. And I have to say that, you know, this breaks up a lot different, and I don't think it's quite as good as the DJI yet, but I am hopeful for Fatshark, and they're continuing to improve upon this rock solid product, which I believe is a really good beta product. This is probably one of the best beta products I've ever actually tested. Out of the box, everything just works. It is a really good system. It definitely could use some improvements, but I think that we're going to see that, and it's in the forums, and they're listening to the support from you guys, the community. So, you know, if you have the Sharkbyte, please feel free to join the Facebook group online and add and contribute to, you know, this awesome community project. I really feel that this type of breakup, because of the lower latency, if we could improve upon that, I think we would really have something that could really compete with DJI in the future. But put your comments down below. Let me know what you guys think about the range testing and the penetration testing of the Sharkbyte. How do you like to break up versus the way DJI breaks up? Obviously, it's completely different. It doesn't pixelate, it just gives you that digital static, which really does remind me of analog. But the picture quality for me, even on my HD3s with the LCD screens, I'm really quite happy with. It's definitely an improvement over my analog. So I would say if you were on the fence about getting Sharkbyte and you have analog, I would say go for it. I mean, it's definitely a better image quality than analog, no doubt. If you can, fly through the digital static, I think you're going to be really happy with this product, and it's going to feel right at home, especially if you're used to the way the analog breaks up. This is going to give you, key notifications when you need to turn around and when you're pushing the limits of your range for the Sharkbyte HD system. Thank you guys so much for watching, and please like, share, and subscribe, and put down below your comments about how you think the new Sharkbyte HD system looks. What do you think about using this over analog? Do you see any noticeable improvements? I'd be curious to know what you guys think. Put it down in the comment section below. And until next time, guys, thanks for watching. eDrone out.